My name is Luigi Annunziata. I am the EMEA Technical Business Development in Nuage. Nuage Networks is the SDN division of Nokia. I will give you some information about Nuage, what we do. We do SDN, and so we talk how SDN is related to OpenStack. So this is the agenda. We see Nuage, just a few information. How this is correlated to OpenStack. How Nuage will plug in OpenStack, and what add as capability, as information to OpenStack. I will give you some information on the platform, and I will show some code. To be honest, we have just 20 minutes, so I have a demo on my laptop. If you are interested, I can show you more code, more information. Also, we can access to our platform. We have a platform in the cloud, so I can show you how to consume Nuage. Because the idea is that we program the network, and with OpenStack, you can consume, you can use this information. OpenStack is just a flavor. We will see that this platform fit also with the VMware, with Hyper-V, with containers, whatever you want, with bare metal server, so servers that are not virtualized at all. Let's start from the OpenStack, so from the native networking. This is just a representation of a host. These are two virtual machines, can be the same tenant, different tenant, and these are the elements that are involved. You see that this part is managed by Nova, that is the phasing network part of host. This is managed by Neutron. As you see, the result is a lot of complexity, because we need to manage all these elements. And even if you try to have troubleshooting, you need to start from one point and go step by step for the troubleshooting. So we start from this, and we try to optimize and put simplification in this draw. This is what we propose. Maybe you already see this idea. The idea is to use one single OVS switch. OVS stands for Open Virtual Switch. It's a flow-based switch. It's a layer 2 switch. On this switch, we put also a small part of control plane to add other functionality. The idea here is that the virtual machine, that can be also containers, is directly plugged to our vSwitch. And you can see that programming and orchestrating this is much simpler than this. Of course, there is still the problem of how I can program, how I can scale my infrastructure, how I can distribute this information, and so on. Let's see how we solve this. This is another draw. When we consider also that our OpenStack needs to talk with the external world. So I would like to have additional function to talk with the external world, and the idea is to implement this functionality in a distributed way, in a distributed fashion. How we can do this? Think functionality like inter-tenant between different routing or floating IP, all in distributed fashion. With Nuage, the draw is always the same. So we have one single vSwitch. We plug everything, even if these are two virtual machines from two different tenants. And on this, in this part, we realize functionality of layer 2, layer 3, firewalling, also functionality like isolation. Maybe some of you already know what we mean for microsegmentation. As you see, the name is ALU bridge. This stands for Alcatel-Lucent bridge, because initially we was the SDN division of Alcatel-Lucent. Then Nokia bought by Alcatel-Lucent, and now we see Nuage from Nokia, but we still try to maintain our independence to be more agile, flexible. So what functionality we can implement in this? Of course, we can perform switching, routing, NAT. We can process locally the ARP, the DSGP. So these functionality are always implemented in a distributed fashion. Why? Because when a tenant needs to talk with another tenant, we don't need to flood any traffic. We try to eliminate the so-called BAM traffic, broadcast and no multicast traffic. Why? Because we already have this information, because when we span a new virtual machine, we already have this information, so the MAC address, for example. We take this information and distribute it to all others OVS switch in our data center or in our data centers, because we can talk not on a single data center, but a lot of data center. This is the idea. And to implement this functionality, we don't need to leverage on a central dedicated network node. So the tromboning of traffic, we can eliminate this, because everything is distributed. Just to give you last example, this is what happens if the tenant needs to talk with the outside world, with the internet, and this is what Nuage propose. The idea is they have this open switch that we call VRS, Virtual Router Service. Is an open switch. We don't produce open switch. It's the OVS of your Linux distribution. We just add some code to program this OVS. So we don't have any implication with the kernel, also an upgrade. We don't upgrade your OVS switch, but just the control plane that we put on this. To have this communication, we use VXLAN. Of course, VXLAN is a standard. And to talk with the external world, we can use the VTAP. So a network element that can terminate the VXLAN. We can have this VTAP in software, in hardware. When you talk about hardware, because if you want performance, you need hardware VTAP. Pay attention, because there are a lot of hardware VTAP that are layer 2 VTAP. This means that the virtual machine, the external world load, needs to be on the same broadcast domain. We support layer 2 VTAP, but our VTAP are always layer 3. So we can route between VLAN, between VXLAN. For us, it's the same. And we can integrate this with a lot of a third-party hardware VTAP. This shows just how we plug our solution in OpenStack. We plug as a Neutron plugin, so the user can still use the Neutron API, can still use the Horizon, same as always. But all the functions are implemented in this plugin. We have two form factors. One is the monolithic plugin, so everything in this plugin. And another one is this one. Is more complicated, but is just the ML2 plugin, modular layer 2 plugin, that enables the possibility to use different drivers. Just as a reference, I will leave this slide that show which are the models that we support today. This is the standard OVS switch. That means that I have one single OVS switch in every host. This is the so-called accelerated OVS switch. That means that we can dedicate a particular core to switching a function. You need DPDK from Intel, Data Packet Development Kit, and you can use this. Another model is this one. Maybe this is specific for telco cloud environment. The idea is that we can skip the hypervisor, skip the OVS switch. We can plug directly the Ethernet interface directly to a VLAN. And this VLAN is programmed also on the hardware VTAP. On the top of the rack, where is plugged your server. This is another model where you need an offload by the NIC, because encapsulation and decapsulation of VXLAN is standard. So if you have a particular NIC, for example, I see a guy from Mellanox. Mellanox is our partner here. We can offload the encapsulation and decapsulation of the VXLAN, and so we can have a performance really near the line rate. So 10 gigabyte, 40 gigabyte, and even 100 gigabyte. And this is the mixed model, where we use DPDK for switching and the Mellanox card or other card. So let's see what Nuage add in terms of functionality, in terms of feature to a standard OpenStack. I just put some of the common feature that are comes from native OpenStack. So you do already have distributed switching, routing, even if the architecture is a little bit more complicated. You have FIP, BGP, QoS port rate limiting, and so on. This is just a list of what Nuage can add. We implement this functionality in a distributed fashion. Also, the source NAT or the floating IP we can do in a distributed way. Just talking about the BGP. The main component of Nuage that we will see in the next slide, couple of slides, is our controller. Our controllers comes from a virtualization of a physical router that comes from Alcatel-Lucent. Why I'm saying this? Because this router has more than 10 years of development in a service provider's environment. So our BGP is extremely rich, is extremely powerful, rich of import-export policy control. We can extend our domain, our virtual router, also to a physical router. About the QoS, we can do rate limiting on this, but we have a very flexible QoS, so we can do tagging, remapping, and so on. This also is important, policy basing traffic mirroring. What means that I can define a policy and say this traffic, please mirroring on this mirroring object. The mirroring object can be a physical interface, a logical interface, an address in the underlay, whatever you want. And of course, this is a policy. If I move my workload from one data center to another data center, this session will follow the workload. But again, we have cross-tenant routing. This means that we can have two OpenStack projects, and we can manage the routing between these objects. Direct routing to underlay. This means that our FIP can local break out the traffic on every host and directly put the traffic to the underlay. So I give you just a vision of our three components. We have an SDN platform, and so SDN platform, you know, that is mean we have a central control, and we have a distributed forwarding. To connect the controller and the forwarding, we use OpenFlow. This is the generic idea of SDN. We start from this. VSD stands for Virtualized Service Director. Is our policy engine. Is where we configure our policy. And here you can program your network. You can also chat with your network, because you can ask which are the domain, which are the subnet, who is using this, and so on. We can use the graphical user interface, or you can use RESTful API or one of our SDK. So you can use Python, Go, Java, Ansible, whatever you want. The VSD, that is the management layer, and remains always one. Talk with the controller. This is the virtualization of our physical router. They use XMPP. XMPP is just a chatting protocol. Of course, each controller have some scaling limit. For example, one controller in our solution can manage until 1,000 physical hosts. This means 1000 physical hosts where I run my virtual machine. But this is not a real limit, because if I reach this limit, I can add another controller, I can federate this controller. How I can federate? With BGP, is a standard BGP, I can scale to more than 1000, and to more than 1, 2, and data center. Because we don't have the limit of a single data center, 2 data center. We can manage a list of data center. This is the fabric, and the fabric is just a layer 3 fabric that I use to enable this OpenStack session. So I have my controller and my forwarding plane distributed on the host. We are talking on this one. This is the KVM flavor, but for us this is the same. Even if we have Hyper-V, we have the same OVS switch with our control part, this flavor, or for VMware. What can enable this? This enables to create in my VSD a subnet, and when I create a subnet, I specify also a policy. A policy can mean, just an example, I have two subnet, A, B. Subnet A is allowed to go on internet. Subnet A can talk with the subnet B just on this specific port, TCP, UDP, whatever you want. You can also define subnet B is not allowed to do ICMP, just because I want to eliminate ping, and so on. When I define this policy, these are distributed in all my environment. So on the same subnet, I can have a virtual machine in OpenStack, and on the same subnet, I can have a virtual machine in VMware, or in a Hyper-V. Or can be also A containers, because, A containers, because for us, it's the same. So if you are thinking to create an application where you have the front end based on KVM, but the back end or the database is a containers or is an Hyper-V environment, you can easily do with this. Because I create all my information in the VSD, and then I can consume, I can use this information using OpenStack or one of this one. Another thing that I can integrate is bare metal server. This is a server. There isn't on this server an hypervisor, so I cannot install an OpenV switch. So I will terminate my VTAP on this physical switch. And the same, I can create some policy, and these policies are applied to my OpenStack, but also to the physical server. When I need to talk with the external world, so you see data center interconnection, I can just create a BGP session with the router. This is a standard BGP, so I can use also a third-party router. On this BGP session, I can export my domain inside a VRF. A VRF is a routing domain on this network element. So let's see how I can code, how I can automatize my infrastructure. Of course, we are present on GitHub. Just Google Nuage GitHub, and you have all the link. But this is really important. So I write nuagex.io. If you go there on this site, you can sign up. It's free. And then we create in the cloud one VSD instance for you, one controller for you, and we deliver also a script. If you have a Linux platform in your data center, you can run this script on the Linux, and this script what to do? Download our VRS, install this our VS, and connect this VRS on our platform. So you can start to create your subnet, and with your workload on premises, you can try. You can also program this VSD. You can try a script, whatever you want. We have also a community and events like this. This is just an example of an API call. So what I was saying before, you can ask to your VSD what are the list of the enterprise or the domain, and so you receive this information. Pay attention that the VSD is one. You can have a list of controller, but you have always one single centralized point, and this controller can cover different data centers. even the cloud. These are some information, some object that you find inside our platform. When you log in the platform, you are inside an organization. An organization is a tenant. Pay attention that this is not an OpenStack tenant. It's just a tenant. This tenant is able to create some domain. A domain, what is a routing instance. Inside this domain, you can create the subnet. These subnet are the subnets that you will find, you can consume, you can use in the OpenStack. So, because this organization is not related to OpenStack, you can have a single subnet where you can plug virtual machine from tenant A, virtual machine from tenant B, but also containers, but also a virtual machine from another hypervisor world. This is the same representation, so we are in the enterprise Ansible test. These are two domains, two virtual router instances. Inside each virtual instance, we have 3 zones. The zone, just for people who comes from the firewalling world, is just a tag that you can use to map a list of subnet. Why use this tag? Because you have a list of subnet that have the same policy. You can just use this tag to define a policy. For example, I can say all the traffic coming from a web zone is not allowed to do in the database zone. So all the subnets that you add in this zone will receive the policy. And this is what happened as a visualization when you plug a virtual machine. This is a virtual machine that will be spun in this subnet that is called web subnet that I have defined that have address 10.10.10/24. I can also define policy for the DHCP. I can define a rule. And when the virtual machine is attached to this subnet, he will save the IP address, the policy, and that's all. He is ready to do the traffic that someone has configured for me. To configure this policy, you go on the tab policy. I just create a... We have 2 kind of policy, ingress and egress policy. The name is ingress is the traffic coming inside the Nuage platform, so traffic leaving the virtual machine. Egress is the contrary. And this is just an example of a policy where I said, please block all ACMP or allow ACMP. As you see, with this policy, you can say, okay, I would like to have a microsegmentation on this subnet because ICMP is not allowed. I click create this policy. When the policy is applied, everything is connected, is plugged to this network, will receive this policy. And you see here, there is also mirroring. I can also decide to mirror this traffic. So I can create a mirroring object. And on this tab shows the interesting traffic. This side is very simple, from any to any. But here I can use a subnet, I can use a macro to specify an IP address, or I can use a zone. So here I can say from web zone to database zone, please do this, please do mirroring, please whatever you want. Just the last slide on the code. I used Ansible SDK, just because Ansible is the latest one. Okay, I will terminate. This is what I need to connect. So CSP stands for Cloud Service Provider. And I will log with the Cloud Service Provider root. With this I have all the privilege, so I can create my enterprise. This is the enterprise that I will create. My domain and so on. Just to give you an example of what we create. In this way, in a so-called human readable fashion, we create a web subnet. If you remember, was 10.10.10/24. Here I can create this subnet, this template. I can also create some policy. We didn't see. This is the policy who allow ICMP. The header type, this stands for IPv4. There is also IPv6 is coming. This is what the rule that I can do with this. So If you are interested, I can show you how to use through the graphical user interface, and then what it means to create a domain, to apply a policy, to program this. This, of course, fits for OpenStack, but the important thing is that if you have OpenStack and you have another environment that can be containers, VMware, Hyper-V, we can do the same, exactly in the same way. This is last slide. So we see this part. So we are here on KVM, but our platform fit in all this environment, and this is really important because today, also for the adoption of OpenStack, it's rare that you will find a greenfield. So if you have already other environment, you can easily plug everything to this SDN layer, and so you can start to create your network, literally drawing your network, define the policy, and also you can split the role, because the network engineer will manage this platform, the host engineering, and the host, depend on the kind of hypervisor, will use this information. We can manage the containers part, and this is the cloud part. Just to give you an example, for us this is only if you have 3 data centers, this is the 4th data center that I can have. And I can manage everything from a single console, my VSD. This is what I see. If you want to try, you can register to nuagex.io. I will create VSD, VSC in the cloud. You can use one of these. This is your private data center. Can be also a virtual machine on a laptop, and you can activate some containers and some virtual machine and can create traffic between them, also with the policy. So for us, having a demo in a multi-hypervisor environment, because on this server I will span some containers and some virtual machine, for me is extremely simple. I think that we are in time. Just if you have any question.
If you have OpenStack deployment with 2 regions, with Nuage, can you create a network that is common to both?
Of course. Yes, because we are independent. OpenStack is just one of the users, one of the tenants that will consume, that will use our infrastructure. I can have also one data center of OpenStack, another region of OpenStack, and a third data center with VMware, with Hyper-V. And for us it's the same. You just need to have the permission to can plug your virtual machine in that enterprise, in that domain, in that subnet, whatever you want. If you would like to see the demo, we should have, because I didn't see, a stand at the ingress of the place. I will be there at least this morning, in the morning. Okay? Thank you.